Hi, boys and girls. Mrs. McGuire here, ready to do our next lesson. So today we're going to take a look at the 30, 60, 90 right triangle. And just like the 45, 45, 90 triangle, this has special relationships with the sides, and it is a right. What happened? Try again. Hi, boys and girls. Nice to see you again. Hopefully you have this printed out in front of you, or you've looked at it, or you're just taking notes on a sheet of paper. But we're going to work through today our 30, 60, 90 degree triangles. And just like the 45, 45, 90 degree triangles, they have a special relationship with this side. And so we're going to start off by looking at an equilateral triangle that has a side length of 2. And so I'm going to give you just a moment to see if you can find the height. Go ahead and see if you can find the height on your own. All right, so let's see how you did. So first of all, I already put the degree measures in there, right? Equilateral triangles, the angles are all congruent and the sides are all congruent. So every side is 2 centimeters. And we need to draw in the height. I'm going to use this vertex here. And when we drop down this height, we've learned several different names for the height of our triangle. But when you're thinking about the height of this triangle, hopefully there's 4 other names that come to your mind for this. I'm going to put a little H on it for height, but it could be an altitude. That's one of the names that we learned for the height of a triangle is an altitude. Now, because we're working with a special triangle, an equilateral triangle, the altitude can also be 3 other things. And so hopefully you're thinking of a perpendicular bisector. So that means that, yes, it is bisecting this side here. So instead of 2 centimeters, we know that both of these are congruent to one another and they're 1 centimeter apiece. And then we also have an angle bisector, which means that the angle here is being bisected. So this 60-degree angle is a 30-degree and a 30-degree angle. And then one other word, we kind of already used it in the perpendicular bisector, but it's a median. All right, that's good review for us. I love that. But our focus is going to be, and I'm going to highlight it for you, we're going to focus on one of these two 30, 60, 90 right triangles. You should realize that they're congruent. We've talked about that before, that we've got congruent triangles here. So I'm just going to highlight it, the one on the right in yellow, and we're going to focus on this one. And so far, you can see 2 sides out of the 3. So we're going to go ahead and find the height using our good friend Pythagorean theorem. Hopefully that's what you did. So c squared equals a squared plus b squared. Our hypotenuse here is the 2 centimeters. And then we'll put in the base, right? Our a and our b. Sorry, not the base. So we've got 2 squared, which is 4, equals 1 squared, which is 1, plus h squared. So h squared is equal to 3. And taking the square root, h equals the square root of 3. All right, so this is one representation of a 30, 60, 90 right triangle representation. This is a Pythagorean triple. And we can take this and multiply it by anything and make lots of different triangles that will be similar to this one. So they could be all different sizes, but they'll keep the same shape. And so we're going to go ahead and just bring what we've learned down here to the bottom. I have created a 30, 60, 90 right triangle for you down here. And a couple of things you need to understand is that the hypotenuse, BC, is always going to be the hypotenuse. So just let's label that. This is your hypotenuse. And then you have the two legs. And in the 30, 60, 90 triangle, the leg opposite the 30-degree angle is shorter than the leg opposite the 60-degree angle. And so we're going to refer to this as this is our long leg, right? Opposite the 60 degrees, because 60 is bigger than 30. And then opposite the 30, this is our short leg. Right? So you've got a hypotenuse, a long leg, and a short leg. And we are going to, everything that we do is going to be easiest if we start with the shorter leg or the shorter side. And that's going to be where we do our X from. In this triangle up here, it's 1. So we're going to call it X. And then the hypotenuse, if this is 1 and this is 2, our hypotenuse is twice the length of that shorter leg. And then our longer leg, right, if this is 1 and this is the square root of 3, our longer leg is the short leg times the square root of 3. And so this is the relationship that we're going to look at. And again, some of you are going to be very intuitive. You're going to notice the pattern right away, and you're going to be able to recognize the pattern and use it quite simply. And there's others of us that are going to use a formula. So this one has 2 formulas because there's 3 different angles and 3 different sides. So the short leg is always going to be starting with the X. The hypotenuse is going to be 2 times the short leg. And then the longer leg is going to be the short leg times the square root of 3. And so these are the 2 formulas that you want to memorize right here. If you used formulas in the last triangle, you're more than likely going to use formulas for this triangle. It'll be really helpful. But pretty soon you might see patterns forming as you use the formulas, and you might be able just to say, oop, I got the pattern. I don't really need the formula anymore. But the formula is great to get you started. All right, so we're going to do a couple of examples, and I created these examples to kind of ramp up. So they start with the easiest types of problems that you're going to see, and then we'll end with the harder ones. And you're going to see they're really not that bad once you get into this idea of looking at this pattern. So let's go ahead and take a look at number 1. Number 1 is a representation of the simplest type that you will ever encounter. And you'll notice that we are given the shorter leg. And everything stems from the shorter leg. So anytime you get a problem where you're given the shorter leg, it's going to be the simplest one to handle. All right. So let's just use the relationship that we see, right? The hypotenuse is twice as long, right? The hypotenuse is twice as long. And it should make sense to you that the hypotenuse is the longest side, right? So 2 times X is the most that you're going to get. X times the square root of 3 is the middle side, right? It's the middle length. And then this is our shortest one, just plain old X. So when you look at this problem, it's as simple as going, across from the 90-degree angle, our hypotenuse is 2 times 5, 10. And this is our 60-degree angle, right? That's what's left. So across from our 60-degree angle is the shorter side times the square root of 3. So it is just 5 square root of 3. Ta-da! Now, if you want to use the formulas for that, you can. I don't think you're going to need them. When we get to the harder ones, we'll jump on the formula and you'll see what I'm talking about. All right, so number 2, not bad. It fits the pattern beautifully. Look at number 2. They give us the hypotenuse. So anytime you're given anything that's not the short side, you're going to find the short side. You always find the short side first and then work through the patterns with what you know. Makes it much easier. So if we know that the hypotenuse is 24, we know that the shorter leg, the x in this problem, is half of that. So x is going to be 12. All right. And then to find the longer leg, that's opposite our 60-degree angle, we're going to do the short side times the square root of 3. So it's just going to be short times the square root of 3. Ta-da! All right. I'm going to let you try number 3. Number 3 is a little bit different. They start you off with the longer leg, but hopefully you can see the short leg right there with it. All right, so did you come up with the short side, right? If this long leg is the short leg times the square root of 3, you should be getting x equals 10, right? Because if this is 60, this is 30. Now, if you did not see that, you are going to use the formula. And I'm just going to do a L for long leg and an S for short leg times the square root of 3. So the long leg equals the short leg times the square root of 3. We were given the long leg. So we're going to put that in. And we are finding the short leg, which is our x. And you might even be looking at it going, okay, x has to be 10. But if you're still not seeing it, take x and divide out that square root of 3. And there you go, x equals 10. All right, so now that we have the short side, we just need to double it to get the hypotenuse. So 10 times 2 is 20. There you go. Beautiful. Let's try another one. I always have more for you. So number 4, I'm going to give you a minute to try that one on your own. All right, so number 4, they started you off with the hypotenuse. We love these kinds because we can find the short leg in a snap, and your short leg is 11. And then that means you're going to do the longer leg is 11 times the square root of 3. Okay, so number 5. I'm going to work through number 5 with you. Number 5 and number 6 represent the hardest kind that you can get, and they're not even that bad. So number 5, they're giving us the long leg, but it's not in the consistent, cute little pattern, right? We'd expect to see short leg times the square root of 3. We don't see a square root of 3 here. So we're going to use the formula, long leg equals the short leg times the square root of 3. And we're going to plug in what we have. We have the long leg, which is 9. And our short leg is the y this time. And you always want to find the short leg first, no matter if it's the x or the y. Just go for that one first. It makes life much easier. All right, so we're going to divide by the square root of 3. And really, you guys should be getting really good at this by now because it's not that it's hard. It's just that we need to stop and rationalize the denominator. So our y value is 9 divided by the square root of 3. We're going to multiply that by 1 in the form of square root of 3 over square root of 3. So our answer for y is 9 square root of 3 divided by 3, which will reduce to 3 square root of 3. All right, so once you have the short leg, go ahead and find the hypotenuse. Did you get it? You're just going to double this answer, right? And how do we double that? We're just multiplying by 2. So it's 2 times the 3 outside of the radical. So our hypotenuse is 6 square root of 3. Okay, you go ahead and try number 6 on your own. See if you can come up with the x first, because that is the shorter leg. All right, to find x, we're going to do the same thing we did in the last problem, and I'm going to use my formula until I get really good at this. So the leg equals the short side times the square root of 3. Our leg this time, our long leg, is the 15. And our short side opposite the 30 is the x. And then we're going to go ahead and divide by the square root of 3. So x equals 15 divided by the square root of 3. And we rationalize. right? So x is going to equal 15 square root of 3 divided by 3, which reduces to 5 square root of 3. And how about that hypotenuse? Did you double it to find the hypotenuse? So to get the hypotenuse, we're just going to double the 5, and it's going to be 10 square root of 3. There you go. All right, one more problem. It looks a little bit different. But you got this. Go ahead and find the short leg for number 7. All right, so for number 7 here, we have got the hypotenuse, right? And it's kind of strange, but we just need to cut it in half. Did you cut it in half? Divide by 2 so that x is 9 square root of 3. All right, and then to find the long leg, remember the long leg equals the short leg times the square root of 3. So to get y, we're going to do 9 square root of 3 times the square root of 3. Square root of 3 times square root of 3 is 3, and 9 times 3 is 27. All right, one last problem, and I really want you to try this on your own. Draw a picture and use your 30, 60, 90 right triangle. It says find the height of an equilateral triangle with a perimeter of 24 inches. You are just finding the height. All right, how many of you guys got 4 square root of 3? So let's draw a picture together. An equilateral triangle. And we started off with this example. Dag, that's a great triangle, Mrs. McGuire. All right, so all of the sides are congruent, and all of the angles are 60. And if my perimeter is 24, I'm going to divide that up equally by 3. So that means I have 8 inches on every side. Now, you notice I did not put the 60 degrees up there because you know what's going to happen when I drop the height, right? The height's coming down. There it is. There's the height. And this is my angle bisector, my perpendicular bisector. So I've got 30 degrees up here. And I have that side that was now 8 inches is 4 inches for each. All right, so the height, we're using our 30, 60, 90 right triangle. That is the longer leg. So height equals the shorter leg times the square root of 3. So it's 4 square root of 3 inches. Now, make this problem even more interesting if I just asked you to find the area, right? Could you do that? Think about that. All right, there's assignment waiting for you. The worksheet is waiting for you. And of course, I will upload the assessment for that to keep you accountable. But meet me at Extra Help Thursday after school if you need help. Otherwise, God bless you and have a great day.